That's the idea of it being a random sample, that it's a representative sample, that it represents the population. And so a statistic is calculated on a sample where a parameter comes from the population. And that's usually what you're trying to estimate. If you got a small enough population, then of course you can calculate, and it's still called a parameter. But in most cases, it's still the same. The only thing that's different is that standard deviation. So chapter 2 is when things get meaty. Let's see, which is the best one of these to look at. So you remember how to construct a frequency distribution? If you got one like this here, where the classes are already kind of decided for you, they're the A, B, C, D, and F, then all you got to do is just count, write the A, B, C, D, and F1 and once, and then write the frequency. All right, so here's one. That's a frequency distribution, and it has full classes in it. And we're just going to ask a question about it. How many classes are there on this thing? 1, 2, 3, 4, 5, 6, 7, 8 classes. There are 8 classes there. The class width is simply the difference between any two successive ones. So 40 from 60 gives you 20 as the class width. That's how many values are in each one of the cubby holes. Now, a relative frequency distribution is just going to keep adding them along here. I'm not going to go ahead and create one of these, but you have 15 here and 25, and then add 13 to it, and just keep going all the way down where you're adding all of these each time. That's what that cumulative frequency distribution is. Oh, I'm sorry, it's not cumulative, it's relative frequency distribution. The relative frequency distribution is just where you take each one of these and divide by the total. So let me share the whole thing, and then we can use that calculator here. So the relative frequency is just taking each one of these frequencies and dividing by 50. So 0.04, 0.26, 0.2, and that's what's called relative frequency, and we do that for all of those. And then all of those should add up to 1 when you do it. And that would be what would be right here in that column. Now, the only thing that changes on the relative frequency distribution, it's just that you don't, on the histogram, is your column here is going to be in the percentages, or actually the decimal equivalents. That's the only thing that changes. The shape is still the same. The proportion is still the same. And then just to look at some questions, in what percentage of elections were 100 or more freshmen elected? So this was the number of times. So this right here is the number of freshman senators that were elected. So like right here, it's 100. and it says 100 or more. So in order to answer this question, you would add up 1, 2, 3, and 4, those 4 things. So that's 12 divided by 50. So 0.24, which is 24%. And what percentage of electors were fewer than 60? So fewer than 60 would just be these two. So that's 15 divided by 50. 0.3. So you can also do the same thing. This is a frequency, a histogram represents something very similar. And you can answer questions in the same way, except that you got a visual chart. How many students took the quiz? Well, you just add all these up. They don't tell you here like they did on the top one about 50, but you're going to add these up. That's 1, 4, 5. Let's see if we can add them up. 1 plus 4 plus 5 plus 6 plus 12. And that's 11. 6 again. And then this is 5. So there are 50 there as well. They do the same thing with the percentage, less than 6. So that would be these 3, the frequencies added up, divided by 50. Scored 10, so that would be this one up, 5 divided by 50, which is 10%. Now, these questions are about the layout of the histogram, and this is one of the most important reasons why we have a histogram, is that we can use it to tell us about the pattern of the data. They mentioned unimodal and bimodal. Well, there's only one big hump in it, so it's unimodal. If you had like a saddle in there with 2 humps, then it would be bimodal, but this is unimodal. And you can say that this is approximately symmetric. It starts out low, gets high, gets to one hub, and comes back down. So chapter 3 is where we start doing actual calculations, remember? All right, let's see, what are they asking for here? On the mean. On this, you don't, you could put it in the column and do it. I'm just going to do it like this. So 270 divided by 9. So the mean there is 30. Now you remember the median. In order to find the median, you've got to order them. So we got to order them. Let's see. So the lowest one looks like it's 304. and 3. Oh, I'm sorry. There's 288. One, two, three, four, 5, 6, 7. So we got to find the middle one, which is this one, correct? Because when we select that one, we got 3 on either side. So the median is 398. All right. So here we got a couple of standard deviations. I noticed that this right here says it constitutes a population. This one says standard deviation of the sample. Both of these are standard deviations, okay? Well, I'm going to use the calculator for it. If you haven't figured this out, then this is going to be your chance to figure it out, to learn it. Let's see. I'm going to do just one of them. Because the calculator does both the sample and the population standard deviation at one time. All right, 1, 2, 3, 4, 5. There's just 1, 2, 3, 4, 5. Because if you're doing this by hand, you got to calculate the mean and subtract it from each one of those and take that difference, deviation, and square it, and then add them all up. And then divide by the number of pieces, or in number of pieces minus 1, and then take the square root. Now, so the very first one, you just got to go over to calc and hit enter. Now, if you have not figured it out, there's both standard deviations there. S is the sample. Sigma is the population. So it gives them both to you. All right. So I'm going to see. If I can change this real quick. It's going to be weird to change that. I don't know how to do it offhand. Well, anyway, I was just going to show you that on that one too, that you get both of them. You just got to remember, S is the sample. That bottom one, the sigma x, is the population. All right, so the empirical and the Chebyshev rule. The important thing here is empirical rule's got three different percentages. It's got 99.7 or almost all, 95, and 68. Chevychev's only got two. It's got 88.9%, and it's got 75%. So, if, see with this one right here where it says at least 75%, and again, here's another key thing that makes you know that you're dealing with Chevychev because it has at least. All right, when you got that in there at least, that just means you're using Chevychev. So at least 75%. So that's just one standard deviation for 75%, two standard deviations. I'm sorry, whoa, back up. Two standard deviations is 75%. Three is 89%. So what you would do is two standard deviations. So 2 times 17 is 14,000. So subtract 14,000 from 58 and add 14,000, and that would give you the two endpoints. So empirical rule, technically, is for when you're dealing with normally distributed data. Chevychev is when you don't know the layout of the data. It could be normally distributed, but if you don't know, or if you know it's not normally distributed, then Chevychev is what you use. And it's going to, Chevychev is going to be less accurate because remember, it's got the at least thing. If you're talking about two standard deviations with the empirical rule, it's 95%. But on Chevychev, it's at least. And then the same thing happens. Like, for example, here it says, assuming a bell-shaped distribution. All right, so that means you go into the 68 and the 95 and the 99.7. And so find the approximate percentages of workers that earn between 47.3. I would almost guess that that's one standard deviation. Let's see, it might not be right, but let's see. Yeah, 47. So that's just one standard deviation down. So the percentage of workers between these two values is 68 and 95%. All right, now this right here is one of the important things in the chapter, and it's kind of the highlight of chapter 3. It's where you're dealing with finding an outlier. Remember, they're giving you these things here. You're not having to calculate them. So that's part of the, I guess you would say, that kind of cuts down on the amount of work that's to be done. It could give you, in the calculator form, because remember, if you do that same thing and you go down here, they could give you that. All right. They could give you that information right there, same information that's there. So they could give you the screen printout. That's one of the favorite things for them to do on the exams. And you probably had one like that on the midterm, but let's look at what we can do. All right. I'm just going to do it with a calculator because it's going to be quicker. I'm not going to write it down. All right. So, Q3 minus Q1 is what we call the interquartile range. Interquartile range, let's see, so that's 74, take away 53. So 21 is the interquartile range. We multiply that times 1.5, Now, that's what we add and subtract to Q3 and Q1. So 53 minus 31.5 is 21.5. So 21.5 is not lower. I'm sorry, 28 is not lower than 21.5, so therefore it's not an outlier. 74 plus 31.5 is 105.5. Yeah, it's right there. You can't see it? Is anybody else having the problem? Because remember, I got two computers up so I can know that what I'm showing, but if it's other people that need, I can refresh my screen. Did you try refreshing? Is anybody else not able to see it? I mean, I can refresh it and just see what happens. But like I said, I got two computers up, one where I'm a visitor like you, and I'm seeing it. All right. So 105 is your upper outlier, upper boundary for outliers, and it's below this. So this one right here would be considered an outlier because it's below. Because what these two boundaries create, what was it? It was 21.5 and 105.5. That's your lower and your upper boundaries for outliers. The lower boundary, if this was your minimum piece of data, we're fine on that end. But on this end, that would be considered an outlier. All right, can you see it now? All right, so that's pretty much the chapter 3. I mean, you got your mean, your median, the mode, standard deviation. It's most so far. You got the empirical and Chebyshev, and then you got your outliers. And this is what they call the 5-number summary. And you also did that box plot in here. They don't ask us to do it, but we could draw the box plot with these things if we wanted to, if we were asked to. All right, so probabilities are always going to be between 0 and 1 inclusive. So in other words, if something cannot happen or will not happen, its probability is 0. If it is certain to happen, it's 1. All right? Remember what a sample space is? Let me remember the sample space is all the things that can possibly happen for an experiment. I'm going to use this because I can edit right on this. So the sample space, just to kind of get you thinking a bit. So you could have head, head, head. Well, I tell you, we don't need that. But that's all the one with 2 heads and 3 heads. So then we got head, tail, 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 head, head. All right, how about now? When you say you can't see me, can you, is it just seeing my face or seeing the presentation? Well, I mean, it can freeze up for one person, no doubt, but so just, all right. So sample space is just all the things that can possibly happen. All right, so this is one of those popular ones I remember seeing on the final exam from time to time. All right, things that cannot happen probability wise. All right, you can't have a negative probability, and you cannot have a probability that's greater than 1. All right, all of these others are fine. Same thing they're doing here. Remember, they also have to add up to 1. So, It adds up to 1. So that one's fine. You can see, actually, this one is going to go over because 0.35 and 0.05 is 40. See, that one's no good. And then this one is also bad because it's got a negative probability in there. All right, so the general rule is just or means add. All right. Now, if P and B are mutually exclusive, then this right here is 0, and you just got these two to add up. And this is the little thing that they use in this text. It means complement. So those things have to add up to 1. The probability of something happening and it not happening have to be 1. So at least 3. So at least 3, and the way to put that is, it might help if you write it as in that way. That's what at least 3 means. 3 or greater. So the complement would be x is less than 3. Or you could say x is less than or equal to 2. Either one would be the same thing. This one kind of makes a little bit more sense. But if you're dealing with discrete values like this, where we're talking about whole, light bulbs, then it's going to start at 2. All right, Joe, okay? Okay? All right. All right, so the addition rule is for or. Or means add. Let me just write that out here. If you can kind of get this, wrap your head around this. All right. So if the events are independent, then it's simply multiplication. And means multiply. See, and, oops. So the general rule, it's kind of confusing the way that they write it, but this one works for whether it's independent or not. And I think they even break this in two and do it the opposite way as well, but it just means multiply. All that this means is that little line right there, because if they're dependent, then this simply reflects any change that happened from probability A. So this would just be the probability of A times the probability of B given that A occurred. And the best way I know to describe that is it's the idea of like a deck of cards. If you have a person pick two cards, you can do it one of two ways. If they're independent, you have them pick the card. Remember, write down what the card is, put the card back in, shuffle up, have them pick again. They're independent. But if you have them pull a card out, you shuffle up and have them pick again, then the second pick is dependent upon what happens in pick A. All right. But no matter what it is, you still multiply. The only thing that this means is that you've made an adjustment in probability of B given that A's occurred. So this is conditional probability. So where they got that worded, let's see. Let me go down and look at something real quick. Cheat. Just to make sure I'm not telling you a lie here. So that's chapter 4, 9. Yeah, okay. Well, that's just what I said. The probability of B assuming that A occurs. All right. I mean, I would write it a different way, but let's just say. That's a little bit shorter. Just means it's a given that A has occurred. So this right here is just using the complement. It gives you the probability of lung cancer deaths. Determine the probability was not due to lung cancer. So that's just simply so that's 709 or 70 percent-wise. Just remember, when you're asked for percent, you gotta, after you do your calculation, you gotta shift over 2 decimal places to the right to get the percent. I mean, the reason why we have percents in life is just, for some reason, people's heads, they can wrap them around that better than the decimals. But you can't really do any math with the percents. All right, let's look at this one here. This is number 12 is probably the best one to look at. Like I said, we can't go through every little bit because of the time factor. And if you all want, next week, I mean, Tuesday's not technically out of class, and I'll be around. If you want me to meet briefly, like, and kind of act as a tutor for a short period of time, like half class time or something, I would be happy to do that. All right, informally to do it. It's just, once classes are done, I got to worry about my deadlines because I got deadlines Friday to enter the grades, and so I got to make sure everything's ready to go. But I don't mind helping y'all because I want y'all to do good on this exam. And usually what we've done on the West Bank, and those of y'all from the West Bank, I know Cameron's from over there. On the Tuesday, we would have like a pizza party over there at the student center, and then we have a table set up for each one of the classes, and you bring a review, and that gets your ticket to get in, and you can sit down at that table, and there's somebody in charge of each one of those. So I tried to get that going, but it didn't work out, so I'm just going to try to do it my way. So if you're interested in that, just let me know, because like I said, I can meet y'all on here, and I don't mind giving y'all some help answering questions, because I'm not answering everything. And like I said, if I were you, I would do the one and connect first. You've got it as both homework and a quiz. So use both those. The homework, if you got questions, you can the homework, you can get the help. But when you do the quizzes, that steps it up a notch and kind of simulates your testing. All right, because it's not going to have the helps until you come back and look at it after you review it. All right, so I'm going to do this one here. All right, so probability of an adult. Well, they've got it total for us, so that's nice. And then there's the total of everything. It goes both ways, column and. All right, teenager or prefers to write. So teenager, 80 over 170. See, it's or, remember that means it's add. And then right is 30 over 170. Now, since these have an intersection, so teenager this is where they meet up. When we do that or and they haven't mutually exclusive, then we got to subtract that out because we're using it twice. $80, so that's a 100. so 10/17. Now, just to kind of contrast, if we had said, let's say, teenager or adult, let me just put this probability of teen or adult. All right. Probability of teen is the same thing. It's 80 over 170. And the probability of adult is 90 over 170. Let's see, with these are mutually exclusive. You can't be a teenager and an adult. So that part, like we had here, is 0. And this ends up being 170 over 170, of course. Probably it would have been a better one to just do, have done talk, since they had 3 of them, I could have done talking or texting. And again, they would be mutually exclusive, and it would be 80 and 60. So it'd be 14 over 17. But anyway, I wanted to just contrast that because I remember that was one of the things we had questions about. All right. I'm going to do this one first. D, is a teenager and prefers talking. So is a teenager and prefers talking. All right. So there's 20. So 2/17. Now I'm saving this for the last because it's the conditional one. This is where you got to watch out. Given is going to essentially give us our new denominator. We're no longer going to use 170 because we're given, something's given. It means it's changing the focus now. So we've got to change and just look at those that prefer text. All right. So our denominator is going to be 60. Now, when I showed you this, I told you there was a long way and a short way to do it. You could put down here 60 over 170. And then let's see, is an adult. So adult and texting is the numerator. And for that, you could put 10 over 170. But when you take it and divide, you multiply by the reciprocal, which means the 170s are going to take each other out. And this is what you're left with. 10 over 60 over 1/6. So see, this is the only one, those conditionals, where that denominator changes from 170. Because the given singles out a partial amount. And it singles out those that prefer texting. So we're only going to look at the ones that prefers texting. And out of those, which ones are the adults? Well, it's just 10 of them. Boy, where did everybody go? They're just bouncing in and out. There must be something funny going on with the internet today. A lot of people using it. Um, let me see. The thing is, if it's the voice and the picture of me, that's on one computer, and then what I'm projecting on the screen is my Windows computer. So if it's affecting both of them, it's highly unlikely that's me, but I'll go ahead and redo both just to make sure. Hope it doesn't take away my work there, but anyway. I redid the wrong thing. All right. I shouldn't have reloaded that one because then it lost everything, but you can see it on the video. All right, so I was going to do down here. Okay, this right here, number 13, you got different categories of thing. Remember, this is just your, what they call the multiplication principle. So 5 times 3 times 2 times 2, and that just tells you all the different options you would have. Oops, and I'm not sharing. So 5, 3, 2, and 2. I mean, one of the things that I've learned about dealing with about word problems, and I know those bother people, and I'm no different. But one of the things you do is just go in and look for the numbers. The key thing is how many different choices of paint can we have? So it's just a matter of multiplying those two things. 15 times 2 times 2. So there's 60 different ways. 60 different types of paint. All right. So this is just asking us, we got 4 numbers, and that's what's key here. So we're going to be using this principle as well, but we're taking 6 from 8 times all right, so now let's see, where are those things at? They're over here. No, they're in math. Math, you haven't figured it out, probability. And that's what you want to use. Now, here's the thing is, to do it, you got to put in the first number first. Then you go up. All right, so that's 28 times, and then it's 5, and that's 10, 280. And just to remember, I mean, I didn't have the lockdown browser on my little task because, but yeah, you're going to have that on exam. I think I'd mentioned it, but just remember that. So allow for, time to do that. Oh boy, let's see. Do this last one, I guess. The student needs to select 4 courses from a list consisting of 7 online, 5 hybrid, 6 classroom courses. Assuming the student randomly chooses for the 4 courses, what's the probability of ending up with 2 online? So there's how many? 12, 18 courses. So probably a way to do it with the combinations. I don't know. For some reason not coming in right now. I'll just do it like this. So 2 online. So that's 7 out of 18 online. And then for the second one, it's 16 out of 17 for the online, because you got to have 2, so it subtracts those 2 on each time. 5 hybrid. Now, when you type your hybrid, you've only got 16 left, but you got 5 there. And then for this one, you got 15. And so you multiply those, and you should have that. Let me think about it. There might be a way to do it with combinations and just do it so like this one. But that's going to be a heck of a thing to do it like that. It's a big pain in the neck. I mean, I'll just set it up for you, but it should be the same thing. I'll let y'all do it and report back if it's wrong. So let's see. So 1 out of 6, 1 out of 5, 2 out of 7. All over combination 18-4. All right. Wow, we're almost. We only got like 15, less than 15 minutes, right? All right, so just remember, discrete and continuous is just whole numbers versus anything where you have decimal values or fractional values, anything in between, okay? Any values that are in between. So discrete is whole numbers. That's one of those things I see quite often, all right? I like to get those. Hoping to get through chapter 6 at least. Let's see, because chapter 5 doesn't have a whole lot on in it. Okay, you only have really two things. Most likely, they'll give you something like this little thing. And we already looked at these in chapter 3 where they had like win, lose, or draw. And you just have to add up the probabilities. See, like this one, that's not because the probability is negative. This one is not because they don't add up to 1. That's just 0.4. But what about these other ones? So this is not because that's over 1. So this one is likely is going to be a good one. And you know, and this is one of the things they do like to do is they're putting the negative over here, but the outcome can be negative. It's just the probability can't be negative. So this one is a good one. Now, to just like I said, make things short. This is essentially just doing the same thing that we did with probabilities when we were looking at the frequency distribution. Because remember, probability and relative frequency are the same thing. Also, when we looked at or probability over there, I'll just take you through this real quick. Find the probability that an adult will take more than 2 trips. So more than 2 trips are these two. So that's 0.03 and 0.17. Wait. No, that's right. More than 2 trips. This is the number of trips. So 0.07, so that's 0.2. To do the mean, you multiply all these down and add them up. To do the standard deviation, well, what you can do is put these two columns, and I'll just show you real briefly, because like I said, this is not a major thing, but I just wanted to show you. I wanted to get hit chapter 5 and then look just a bit of 6 if we can. Looks like we're not even going to get it through chapter 5, but see if you do this, if you put 0, 1, 2, 3, 4 in there, and then put the probabilities in there, you can find those things real quick. All right, but this is one of the things because, all right, let me do this one real quick here. This is that expected value. So remember, you just got to get your net winnings. So you're paying $3 for a ticket. So when you buy the tickets, you're only winning 997. So that's important. Always just you're dealing with your net winnings. So, and after you do this, it's the same procedure as the mean for up here. And we have a problem just like this in my notes, or almost just like this. A little bit different. And then the other one is -3. And then here you put the probabilities. So this is 1/1000. 1/1000th, 5/1000ths, and then this is 5, 6, 7, 93. Oops, it's not 93. It's 993. So multiply down on all of these columns. These will all be positive, and that'll be negative. So then you walk those two together. If it's positive, that means that's a that's whether it's negative or positive, it's expected value. But if it's positive, it means there's a gain. If it's negative, it's a loss. So for the person, it's most likely it's going to be a negative somehow. But anyway, I'm going to show you how to do this one real quick before we leave. Because we do leave at 3:15, right? Yeah, because I got a 3:30 plan. All right, so calculator. All right, if you didn't learn to do this, this is a freebie here, okay? See if I can get all of them in here. All right, where is it? It's vars, second vars. And then it's way down here. It's like the 11th one. All right, there's two of them, binomial PDF and binomial CDF. When it says exactly or equal to, then that's the one time you can use PDF. So number of trials, so that's 17. See that? 17. The probability is 0.1, 10%. And then your X value is you want 5. So it's 0.175. All right, now, here's where you got to watch because you got to deal with your complements and all that. All right, so it's for all these rest of them, it's binomial CDF. All right, here's what we got to watch. At most. So what does at most this see? What this does is the binomial CDF is it goes from left to right, just like the table does for the well, all the tables do that. All right, it's just left to right. The way you would get from right to left is you have to subtract from 1. So at most 3. So that would be what this is. So 3 there. That means it'll do 0, 1, 2, and 3. Over let's go 1. Whoops. I messed up. It's still 17. I'm sorry. Down here it's 0.1. And then this one is 3 because at most 3 means 0, 1, 2, and 3. And that's going to take care of everything for you right there. 0.9174. Okay, at least 12. So think about what least means. That means 12, 13, 14, 15. So this one is going to be the complement. So we got to do 1 minus. And so at least 12. So it's 11. So if it's at least 12, that's 12, 13, 14, 15, 16, and 17. So the complement of that is 1 through 11. So that's really small. So that means you got to go over 8 times to the left. We're not afraid. So so this one's just double talk. It's saying who are not afraid. So we don't have to, we can just do it straight. Except it's 15. What? I don't know. I'm gonna have to think about that one. That's not right. If we had 17, it would be 1. What did I do wrong? Anyway, I'm trying to rush here because I got class and I know y'all. I'll have to think about that when we do it again. All right. So if you need help next Tuesday, let me know. And like I said, I'll make